Hi all, welcome to ugcnet. In previous video, we have seen what is left recursion and how we can eliminate left recursion. So in this video, we will be doing more examples on left recursion. So what was left recursion? Left recursion means in the given grammar, if any production is of the form A produces A alpha bar beta, then we call that grammar left recursive, right? So how to eliminate left recursion from the grammar? In order to eliminate left recursion, we have to convert the production into the form A produces beta A dash and A dash produces alpha A dash bar epsilon, right? We have already seen that in our previous video. So let's move on to the questions. Our first question is A produces AC bar, AAD bar, BD bar, CD. So just look and tell whether this grammar is left recursive or not. Yes, this grammar is left recursive. Why? Because here we can see that the left hand side is capital A and here in the right hand side, two of the terms starts with capital A. So it is of the form A produces A alpha, right? So we can say that the given grammar is left recursive. So how can we eliminate left recursion from this? In order to eliminate left recursion, we have to convert it to the form A produces beta A dash and A dash produces alpha A dash bar epsilon. So let's analyze what's the values of alpha and beta. Okay. So beta means the terms that doesn't start with capital A is our beta. So here there are two terms that doesn't start with capital A, right? That means there are two beta values. Let's consider this as beta 1 and the second one as beta 2. Okay. And what's the values of alpha? Here we can see that there are two terms that start with capital A. That means there will be two values for alpha, alpha 1 and alpha 2. So what is alpha 1? Here in this first term, whatever comes after capital A, that is our alpha 1, right? So in this term AC, what comes after A? It is just C only, right? So C is our alpha 1. And similarly in this second term, AAD, AD comes after capital A, right? So that is our alpha 2. So now we can write it like A produces beta A dash, right? Instead of beta A dash, here we have two betas. So we have to write it as beta 1 A dash bar beta 2 A dash. Okay. So what's the values of beta 1 and beta 2? Beta 1 means BD, right? So we have to write it as BD. Similarly, the value of beta 2 is CD, right? So we have to write it as CD. So this will be the first production. And now what is A dash? A dash means actually it is alpha A dash bar epsilon, right? But here we have two alphas. So how we have to write it? We have to write it like alpha 1 A dash, alpha 2 A dash and bar epsilon. At last we have to write this epsilon, okay? So what's the values of alpha 1 and alpha 2? Here we have already found that alpha 1 is C and alpha 2 is AD, right? So we can write it like C A dash bar AD A dash. So this is the grammar which is free from left recursion. This will be our answer. Clear? So let's move on to the second question. Question 2 is S produces A produces AD bar, AE bar, AB bar, AC and B produces BBC bar F. So this is our given grammar. We have to check whether the grammar is left recursive or not. So here in this first production, S produces A. Check whether this production is left recursive or not. What do you say? Is it left recursive? No, it is not left recursive because here in the left hand side we have capital S and here in the right hand side it starts with capital A, not with capital S. So this first production is not left recursive. Now let's check whether the second production is left recursive or not. In this second production, the left hand side is capital A and in the right hand side, two of the terms starts with capital A. That means the second production A produces AD bar, AE bar, AB bar, AC. This production is left recursive. So we have to eliminate left recursion from this second production. And now let's consider the third production. B produces BBC bar F. Here we can say that this production is not left recursive. Why? Because the LHS is capital B. Means it is a variable or the non-terminal B. But the RHS starts with small letter b and small letter f. That means there are no terms that start with the variable capital B. So this third production is not left recursive. So what we have to do? We have to eliminate left recursion only from the second production. Okay. So how we can convert this production? So we have the form A produces beta A dash, right? So we have to check what is the values of beta and alpha, right? So the production is A produces AD bar AE bar AB bar AC. So here in these four terms we can see that the first two terms start with capital A. So whatever term comes after capital A, it is our alpha, right? So here we have two alphas. This small letter D will be our alpha 1. The small letter E will be our alpha 2. And here in these two terms, the third and fourth terms, they doesn't start with capital A. So those two terms are our beta. So AB is beta 1 and AC is beta 2. Okay. So how can we write? Our format is A produces beta 1 A dash bar beta 2 A dash, right? So beta 1 is AB. So AB A dash bar beta 2 A dash. So beta 2 is AC. AC A dash. Similarly, A dash means A dash is alpha A dash bar epsilon, right? So here we have two alpha, alpha 1 and alpha 2. So the form will be A dash produces alpha 1 A dash bar alpha 2 A dash bar epsilon, right? So alpha 1 is D. So D A dash bar alpha 2 is E. So it is E A dash bar. What will come at last? This epsilon. Thus we eliminated left recursion from this A production. S production you can write it as such. S produces A. And the B production also you can write it as such. B produces BBC bar F. So this is our final grammar which is free from left recursion. Clear? So let's move on to one last question. Question 3. E produces E plus T bar T. T produces T star F bar F. And F produces ID. So this is our given grammar. And here we can see that in the first production is left recursive because the left hand side is capital E and here in the right hand side one term starts with capital E. That means the first production is left recursive. We have to eliminate left recursion from that production. Similarly, in the second production, the LHS is capital T and the RHS. In these two terms, one term starts with capital T, right? So the second production is also left recursive. And finally, in the third production, the LHS is capital F, but the RHS doesn't contain any term which starts with capital F. So the third production is not left recursive. So we have to eliminate left recursion from the first two productions. Clear? So how do we convert E and T production? In case of E production, it will be converted to E produces. Actually, it is E produces beta E dash. So what's the value of beta? Let's check what the values of beta and alpha here. Okay. It is E production, right? E produces. So here whatever comes after E, it will be our alpha 1 or simply alpha. Okay. So here we can see plus T. Plus T is our alpha and here this term doesn't start with capital E, right? So this is our beta. Okay. So our production E produces beta E dash. That beta is capital T. So we can write it as capital T E dash and E dash is what the value of E dash? E dash means alpha E dash bar epsilon, right? So what's the value of alpha? Alpha is plus T. So we can write it as plus T E dash bar epsilon, right? So we eliminated left recursion from our first production. Now let's move on to the second production. That means the T production. So here in this T production, whatever comes after T is our alpha, right? So this star F is our alpha and here F is our beta. That means the term which doesn't start with T. So how we will write it? It is T produces beta T dash, right? So the value of beta is F. So it is F T dash and T dash produces alpha t dash bar epsilon. And the value of alpha is star f. So, star f t dash bar epsilon. So, we eliminated left recursion from the second production also. And coming over to the third production, f produces ft. There is no left recursion. So, we can write it as such. So, f produces id. So, this is our final grammar which is free from left recursion. So, now I hope that you know what's left recursion and how we can eliminate left recursion, right? And there is one more section that comes under left recursion, that is elimination of indirect left recursion. How we can eliminate indirect left recursion. That I will be taking in the next video. So stay tuned. See you.